Introduction. Web hacking refers to the practice of exploiting vulnerabilities in web applications to gain unauthorized access or control. It involves identifying and taking advantage of weaknesses in software, code, or configurations. This presentation will cover the basics of web hacking. Here's a simple explanation. Web hacking is when someone finds flaws in a website's security to get into areas they shouldn't be able to access. It's like looking for weaknesses in a locked door. If you can find a way to open it without a key, that's web hacking. This presentation will explain the basics of how this works. Web application vulnerabilities. SQL injection, injecting malicious SQL code to access or modify sensitive data. Cross-site scripting, XSS injecting malicious scripts to steal user data or take control of user sessions. Cross-site request forgery, CSRF forcing users to perform unintended actions on a web application. Here's a simple explanation and real-world example for each vulnerability. SQL injection. Imagine you are ordering food online, and the website asks you to input your name so they can greet you. If someone were to inject malicious code like Robert, drop table customers, dash into that field, it could delete all customer data from the database. This is SQL injection, where bad actors try to access or modify sensitive data by manipulating user inputs. Cross-site scripting, XSS. Suppose you're on a website that asks you to rate a product and includes a review form with a text box. If someone were to inject malicious code like script alert, you've been hacked, /script into that field, it could display a message saying you've been hacked, even if you didn't write it. This is cross-site scripting, where bad actors try to steal user data or take control of user sessions by injecting malicious scripts. Cross-site request forgery, CSRF. Imagine someone tricked you into clicking on a fake button that says confirm order on an e-commerce website, but actually sends your money to the scammer's account. This is cross-site request forgery, where bad actors try to force users to perform unintended actions on a web application by tricking them into making requests they didn't intend to make. Web hacking techniques. SQL injection, using tools like SQLmap to automate SQL injection attacks. XSS, exploiting vulnerabilities in client-side scripts using tools like XSStrike. CSRF, using tools like Burp Suite to identify and exploit CSRF vulnerabilities. Here's a simple explanation for each technique. SQL injection. Imagine you're at a restaurant and you order a meal with a customized ingredient. If the chef takes your order directly into their computer system without checking it first, an attacker could trick them into putting malicious code in the system. This is like SQL injection, but instead of food, it's code that can harm the website. XSS. Think of a web page like a movie theater. An XSS attack is like someone sending a virus to the projector screen, making it show something else than what was meant to be shown. It's not just for movies, though. In this case, it's about manipulating what people see on a website. CSRF. Imagine you're at your favorite coffee shop and they have a loyalty card system where you can refill drinks online. If someone knows your login credentials, they could fill up their own cards using yours, without even being there. This is similar to how an attacker uses CSRF, cross-site request forgery, to make people's computers or browsers do something they didn't intend, like filling out forms with malicious data. Web server vulnerabilities. Apache. Common vulnerabilities include mod_proxy buffer overflow and Apache HTTP server 2.x SQL injection. NGINX. Common vulnerabilities include NGINX PHP FPM-RCE and NGINX HTTP/2DOS. IIS. Common vulnerabilities include IIS 6.0 and 7.0 RCE and ASP.NET 4.0 XSS. Here's a simple explanation for each web server vulnerability. Apache. Imagine you're at a hotel with a big sign that says "Welcome to hotel name." If someone hacks into the system that created the sign, they could potentially add malicious code that allows them to do bad things on the computer. This is like what happens in Apache mod_proxy buffer overflow and other similar vulnerabilities. NGINX. Think of NGINX like a super efficient mail sorter that can handle lots of emails at once. However, if someone finds a way to make it sort emails with malicious code attached, they could use NGINX PHP FPM-RCE, remote code execution, or HTTP/2DOS, denial of service, vulnerabilities to cause problems. IIS. Picture IIS like a web server that hosts lots of websites. If someone finds a way to inject bad code into one of these sites, they could use IIS 6.0 and 7.0 RCE or ASP.NET 4.0 XSS, cross-site scripting, vulnerabilities to take control of the site or cause it to behave badly. Client-side vulnerabilities. JavaScript. Common vulnerabilities include JavaScript injection and DOM-based XSS. HTML. Common vulnerabilities include HTML injection and client-side template injection. CSS. Common vulnerabilities include CSS injection and style sheet manipulation. Here's a simple explanation. Client-side vulnerabilities. When users interact with your website, they can potentially inject malicious code into it. This is called a client-side vulnerability. Imagine you have an online chat where users can type in HTML to format their text. If you don't validate the user input properly, someone could type in some malicious HTML that makes them see something on your page that you didn't intend for them to see. Here are some common examples. JavaScript. If a user can inject JavaScript into your site without proper validation, they might be able to steal sensitive information or even take control of your website. HTML. Similar to the chat example, if users can inject malicious HTML, they could see things on your page that you didn't intend for them to see. CSS. If a user can manipulate your CSS style sheets, they might be able to change how your site looks or even hide important information. The key is to validate and sanitize any user input to prevent these types of vulnerabilities. Web Application Firewalls, WAFs. WAFs can help protect against common web hacking techniques. They work by analyzing incoming traffic and blocking suspicious activity. Popular WAF solutions include Mod Security, OWASP Core Rule Set, and Amazon CloudFront. Here's a simple explanation with a real-world example. What are web application firewalls, WAFs? A WAF is like a bouncer for your website. It guards against common hacking techniques by analyzing incoming traffic and blocking suspicious activity. How do WAFs work? Imagine you're at a nightclub, and the bouncer checks everyone's ID before letting them in. If someone tries to sneak in without an ID, the bouncer stops them. A WAF works similarly, checking each visitor, or user, who tries to access your website and blocking anyone who looks suspicious. Real-world example. Let's say you have a popular online store with millions of visitors each day. A WAF can help protect against attacks like SQL injection or cross-site scripting, XSS, which could compromise customer data or steal credit card info. By analyzing traffic in real time, the WAF can block suspicious activity and keep your customers' information safe. Think of a WAF as an extra layer of security that helps protect your website from common hacking threats. Secure coding practices. Input validation. Validate all user input to prevent SQL injection and XSS attacks. Error handling. Handle errors securely to prevent sensitive data exposure. Secure dependencies. Keep dependencies up to date to prevent exploitation of known vulnerabilities. Here's a simple explanation with a real-world example. Secure coding practices. 1. Input validation. Imagine you're at your bank, trying to deposit money online. You type in your account number, 123456. If the system doesn't validate input, an attacker might exploit this by inserting malicious code, is special in SQL, and causing chaos with your account. Always check user input to prevent similar issues. 2. Error handling. Picture a website that displays error messages in plain sight, including sensitive data like passwords or credit card numbers. This isn't secure. Error handling should be implemented so that errors are displayed securely, preventing exposure of sensitive information. 3. Secure dependencies. Think of keeping your app's dependencies up to date, like regularly updating your antivirus software to protect against known viruses. Just as outdated AV won't catch new threats, failing to update app dependencies leaves you vulnerable to exploitation of known security holes. Stay secure by keeping your dependencies current. Web hacking tools. Burp Suite, a comprehensive tool for web hacking, including proxying, scanning, and exploiting vulnerabilities. SQLmap, an automated SQL injection tool that can identify and exploit SQL injection vulnerabilities. OWASP Zap, a free open-source tool for web application security testing. Here's a simple explanation. Web hacking tools. These are tools used to help find and fix problems, vulnerabilities, in websites. Burp Suite, a tool that acts as a middleman between your computer and a website, helping identify potential weaknesses. SQLmap, an automatic tool that looks for and exploits vulnerabilities in how websites interact with databases. OWASP Zap, a free tool that simulates different types of attacks on a website to find potential security issues. Think of these tools like having a team of cybersecurity experts working together to make sure a website is secure. Web hacking best practices. Keep software up to date to prevent exploitation of known vulnerabilities. Use secure coding practices, such as input validation and error handling. Regularly perform web application security testing using tools like Burp Suite or OWASP Zap. Here's a simple and clear explanation for the given slide content. Keep your website secure. Think of your website as a house with locks on every door and window. To prevent thieves from breaking in, you need to keep the locks updated and strong. 1. Update your locks. Software. Regularly update your website's software to fix any known weaknesses that could be exploited by hackers. 2. Secure coding. Use good habits when writing code, like checking what people input and handling errors properly, so that even if a thief tries to break in, they won't get far. 3. Test your locks. Security testing. Use tools like Burp Suite or OWASP Zap to simulate attacks on your website and find any weaknesses before hackers do. And, just as you wouldn't use special keys with asterisks or brackets that could be easily picked by a thief, your website's passwords should also be strong and not use special characters that are easy for hackers to guess. Web hacking challenges. Vulnerability detection. Identifying vulnerabilities in web applications, including SQL injection and XSS attacks. Exploitation. Exploiting identified vulnerabilities to gain unauthorized access or control. Defense evasion. Evading defenses implemented by a web application to prevent exploitation. Here's a simple explanation. Web hacking challenges. These are 3 types of challenges that hackers face when trying to break into web applications. 1. Vulnerability detection. Finding weaknesses in a website, such as letting attackers inject malicious code or access sensitive data. 2. Exploitation. Using those weaknesses to gain control or access to the website. 3. Defense evasion. Outsmarting the security measures put in place by the website to prevent exploitation. Think of it like trying to get into a locked house. Vulnerability detection is like finding an open window, a weakness. Exploitation is like using that open window to sneak in, gaining control. Defense evasion is like avoiding the alarm system and locks to stay inside undetected. Web hacking strategies. Reconnaissance. Gathering information about a target web application, including IP addresses and open ports. Scanning. Using tools like Nmap to scan the target web application for vulnerabilities. Exploitation. Exploiting identified vulnerabilities using tools like Burp Suite or SQL Map. Here's a simple explanation. Web hacking strategies. Imagine you're trying to find a treasure chest on a beach. Here are 3 steps to help you hack, or rather, explore, a web application. 1. Reconnaissance. You start by looking around and gathering information about the treasure chest, like its location, shape, and color. 2. Scanning. Next, you use a special tool, like a metal detector, to scan the beach and identify any potential weaknesses or vulnerabilities in the treasure chest's construction. 3. Exploitation. Finally, if you've identified a vulnerability, you use another tool, like a crowbar, to exploit it and gain access to the treasure chest. This process is similar to how hackers might try to find and manipulate vulnerabilities in web applications. Web hacking techniques. SQL injection. Injecting malicious SQL code to access or modify sensitive data. XSS. Injecting malicious scripts to steal user data or take control of user sessions. CSRF. Forcing users to perform unintended actions on a web application. Here's a simple explanation for each technique. SQL injection. Imagine you're shopping online and you enter your credit card info into a form. But what if someone injected malicious code that made it look like you entered your credit card number, but actually sent it to them instead? That's SQL injection in a nutshell, a way hackers can trick websites into giving away sensitive info. XSS, cross-site scripting. Think of XSS like a Trojan horse. A hacker injects malicious code that looks like normal JavaScript. When you click on something, that code gets executed, and the hacker can steal your data or take control of your session. It's like having a backdoor into someone else's account. CSRF, cross-site request forgery. Imagine you're on Facebook and see a link from what looks like your friend asking you to click it. But it's actually a scam. When you click that link, it can do anything the hacker wants, like take money from your account or change settings on your profile. That's CSRF in a nutshell, hackers using fake links to trick people into doing things they shouldn't. Web application security testing. A process for identifying vulnerabilities in web applications, including SQL injection and XSS attacks. Helps ensure the security of web applications and prevent exploitation by malicious hackers. Imagine you're a customer trying to order food from an online restaurant. The website asks for your name, email, and credit card info. To protect this sensitive data, web application security testing checks if there are any weaknesses in how the website handles this information. It's like having a special guard that scans the website for potential threats, such as if hackers could insert malicious code into the order form to steal your credit card details. If someone could trick the website into showing them other customers' personal info. The test helps ensure the website is secure and won't let bad guys exploit vulnerabilities. Secure coding practices. Input validation. Validate all user input to prevent SQL injection and XSS attacks. Error handling. Handle errors securely to prevent sensitive data exposure. Secure dependencies. Keep dependencies up to date to prevent exploitation of known vulnerabilities. Here's a simple explanation with a real-world example for each point. Input validation. Imagine you're at a restaurant and you order food online. You type in your address to confirm delivery, but instead of entering 123 Main Street, you accidentally type in a malicious code like select from users. If the website doesn't validate user input, this could potentially allow an attacker to access sensitive data or take control of the system. Error handling. Suppose you're on a banking website and you try to transfer money from your account to someone else's. However, due to a technical issue, the system returns an error message that includes sensitive information like your account number or password. This could be exploited by attackers to access your funds or identity. Secure error handling practices help prevent such exposures. Secure dependencies. Think of it like keeping your home's doors and windows secure. If you have outdated locks or old security systems, they might be vulnerable to exploitation by burglars. Similarly, in software development, dependencies, e.g., libraries or frameworks, can become insecure if not updated regularly. This allows attackers to potentially exploit known vulnerabilities in these components to gain unauthorized access or disrupt your system. Conclusion. Web hacking is a serious threat to web applications and requires a comprehensive approach to security. By following secure coding practices, using web application security testing tools, and performing penetration testing, you can help protect your web applications from exploitation by malicious hackers. Here's a simple and clear explanation for the conclusion slide. Protecting your web app from hackers. Just like locking your front door to keep burglars out, protecting your web app from hacking requires a solid defense strategy. 3 layers of protection. 1. Secure coding. Write clean, secure code that prevents common vulnerabilities. 2. Web security testing tools. Use tools to scan for weaknesses and fix them before hackers find them. 3. Penetration testing. Simulate real-world attacks to test your app's defenses and strengthen them. By combining these 3 layers, you can safeguard your web app from malicious hackers and keep your users' data secure.